The title of this chapter, there's a lot involved, domain, range, and piecewise functions that you can see there. We don't really get to piecewise functions yet today. We will eventually. A lot of today is going to be more interval notation. It's another one of those shortcuts to make life a little bit easier, less for people to write. And domain and range of a function. Domain is pretty simple. Well, apparently it's not there. The domain is basically the x values that are possible, or the x values that actually have a y value that go with it. Okay? And the range is then basically the y values that actually happen. A lot of times when searching for domain and range, it's easier to figure out which ones don't work than figuring out which ones actually are there. And a lot of times looking at the graph is a very simple way of finding out, well, where are x values that actually happen, where are y values that actually happen. A lot of times you can think of domain as you're kind of looking from left to right, and range you're kind of looking from bottom to top, if you want to look at it that way on the graph. So that's just a general definition right there. This unfortunately didn't come across as well as I'd hoped, but interval notation is just a shorter way of writing it. And so let's say that this entire number line, this is the first one I'm looking at here, that this entire number line is where my answers are. Well, all of those get covered, don't they? So what about negative 100? Is that going to get covered by that number line? Yeah, 1 million, positive 1 million, that gets covered, right? And so a lot of times we would say something like this: the set of all real numbers or something like that is how we used to write that answer, correct? Well, we're going to kind of shorten that up a little bit as we go along. We're going to use what's called interval notation, and basically it looks like an ordered pair. What you do is if you use a parenthesis, that means that actual number is not included, because infinity and negative infinity, that's what that is, those numbers are never included. Okay. Basically because they say negative infinity, you can never really get there. Because somebody could always do better. Somebody could always come up with something that's more negative than what you just gave me. Same thing, then you say, how far to the right can you go? And I can go all the way to infinity, but again, are you ever really going to get there? No, because somebody can always do better. Someone can always get a bigger number. So should I include that infinity? No, and what you do is you just use a parenthesis. If you are ever going to include a number, you use a bracket. Okay? And that'll all make sense once we do the next couple, I believe. So this one here is saying there's a number b right there. Maybe it's a 5, maybe it's a 10, who knows, whatever number you want it to be. But do you notice how it's been filled in? And then everything this way has been shaded. So for example, let's say b is, you can use whatever number you want. Let's say it's 10. Then is 0 part of this answer then? Is 0 part of this? You could say domain if you wanted to. Yeah, 0's in there. How about 20? No, 20's not, is it? Because it didn't shade that way. Negative infinity? Yep, positive infinity. No. 11's not even in this answer. So I kind of do it left to right. Negative infinity. Yep, I can go all the way to negative infinity. Can I go all the way to positive? No, I can't. But I can go all the way to what number? To b. Or, if you want to use our example here, let's get rid of b, and we'll just say 10 or whatever you want. And seeing 10 was filled in, can 10 actually be an answer? Yes. It can, so I want to include 10 as part of my answer, right? And to include it, you just put a bracket instead of a parenthesis. It basically means it's included. If I put a parenthesis there, that would mean that 9.99999 is a good answer, but 10 is not. If we were showing solutions to a problem, all of those could be solutions. If we put a bracket around it, we're saying 10 actually is a solution. If we put a parenthesis, we say 10's not, but everything in between 10 and negative infinity is. Okay? It means that number itself is not actually included. For example, in the next one, we have a letter A. Let's put a number there instead to make it make more sense. I don't know, it looks kind of like it's in the middle there. 2. So it's taking 2, and do you notice how it's not filled in and shaded this way then? So for example, is 0 in where it's been shaded there? Is 0 one of those, say, potential answers? No. Is 7 one of the possible answers? Okay. How about 2 itself? No, because it's an open circle. It has not been filled in, which means it does not count. And so what you do, again, go left to right. Well, as I'm going from left to right, there's nothing over here, right? There's no negative infinity. There's nothing over there. The first thing I kind of bump into is the number 2. But 2 itself does not work. How about 2.000001? Yeah, you see, you don't want to sit there and write all those zeros to say the very first number that actually works. See what I'm saying? That's the point here. And what you can do then is say, well, I can go all the way to infinity and never include infinity. Is it possible then to have 2 brackets in an answer? Could you have a bracket on the left and a bracket on the right? Is that possible? And you've already seen parentheses on both ends is possible, right? And this is not the only case, negative infinity to infinity. Over there, look, 2 to infinity. Okay? Lots of times that it could be. So why don't you try A, B, and C right now. Just write interval notation. If you want to scribble it out and put numbers in there, I don't care. Or you can use A's and B's like they have.
So the parentheses are always going to be with infinity because there's never going to be a right answer. Like there's never going to be a set answer.
Exactly. Infinity will always be a parenthesis. Basically, like I said before, somebody could always do better. Somebody could always get further out towards infinity than what you just said. Okay? Yes. Oh, okay. I would say on letter A here, B has been filled in. On letter B, A is open, and B is open. And on letter C, it is open, and then closed would be the word that we would use. Okay? So basically, closed, open, 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 closed. All right, let's take a look at example 1A. And again, you kind of go left to right when you read it, too. You almost have to say something. It's easiest just to probably say parenthesis this, or you could say not including this, and I know what that means. Okay, I can work with it. Yeah. What do you think? Yep. And if you put a number in there, just replace whatever number you put for B where I have a B. Almost looks like a 6, but yeah. Yes?
Bracket A
Yep, and they're both parentheses because, and it's kind of hard to see, but because both open. And letter C. Yes. Again, this is basically all this boils down to is just laziness of mathematicians. They're like, let's find another way of writing this so I don't have to write down all these words. And that's basically all it is. The problem is that some can look like ordered pairs. So you have to be careful and read the direction. Oh, that's an interval. So no, it's not point AB, it's interval AB, not including either one. That's probably the only time it gets a little goofy with that. But again, it's just trying to make things quicker. Yes? If you like writing it this way, yeah, that's always fine if you like writing it that way. Unless the directions say interval notation, then use this. Okay? And I think that's what I'm going to have you do next. Why don't you take out your parent graphs and try and do domain and range with that. I'll do the first couple. I'll do one with you. Maybe I'll do 2 of them with you. We'll take a look at these 2 together. Yeah, it should be in yesterday's notes, basically. And we'll write domain and range in interval notation. And normally what I do for that is pretty straightforward. I think you understand what that stands for. Now keep in mind the graph of x squared does slowly continue to work its way out. It doesn't eventually just be going straight up. It slowly works its way out. It goes up very fast, but it slowly keeps getting wider and wider as it goes. So like I told you before, sometimes when doing domain and range, you're better off trying to figure out where it doesn't work, and then you can help yourself figure out where it does. And I, again, like to go left to right. So do you think there are any x values that are not going to give me a y value? In other words, is there any x value that I can put right there that won't spit out a y value? For example, I can put in -10, that's okay. I can put in 1,000. Yeah, not a good choice, right, because you'd be way up there, but you can, right? And if you look, are there any x values as you kind of go left to right that don't graph some y value somewhere? No, they're not. So you could say all reals is one way to do it, but if we're going interval notation, the easiest way to do it, yep, -infinity to +infinity. At this point, that's when somebody tells me that the range is the same thing. They get going a little bit too fast. Does every y value basically get spit out? No. Basically, yeah, it's pretty much 0 and the positives, right? And so the easiest way is kind of do bottom to top is what I do. Nothing down here, right? There's nothing in the negatives at all. And you kind of find where's the first one I actually hit something, and that is 0. Now, does 0 itself actually get graphed then is the next question. It does, doesn't it? So when I put a 0, what am I going to put to the left of that? A parenthesis or a bracket? A bracket, because that actually gets graphed. If it didn't, you would leave it as a parenthesis. Well, how far does it go? How about 17? 100? Does it keep going? And it actually gets there in a big hurry. All right, it goes pretty fast. And in fact, all of those y values are actually graphed twice. Okay? But it only has to be graphed once. It does go all the way to infinity, and with infinity, don't forget, you will always put a parenthesis. Well, how about x to the third? Is x to the third the exact same answer as x squared? Domain are all x values. Can I put pretty much any x value in I want? And it will spit out some y value, right? All right, and again, you can look here. If I tried that x value, yeah, there'd be something way down there, right? And I could try something way over here. It'd be way off the smartboard, all right? But we do have everything. How about range? Again, you kind of got to do bottom to top with that one because it's y values. Does every y value get taken care of? Yeah, and so what are we going to write? Yeah, pretty much the same thing. -infinity to infinity, they all get taken care of. Okay? Because I could ask you, would -1,000 get graphed for a y value? Yeah. 1 million would get graphed. And everything in between. So any questions, what I want you to do now, go to that parent graph, and you can write it right on your parent graph sheet if you want. Just write domain and range right on there. Okay. All right, let's see how you did. You may notice on here that I do not have x to the fourth or x to the fifth up here. That's because x to the fourth domain and range is going to be exactly the same as x to the seconds. X to the fifth will have the exact same domain and range as x to the third because they're pretty much the same shape. They look the same. What the square root of x? Well, that's a little different. So domain, what x values are possible here? So can I put in -20? Well, if you look over here at an x value of -20, is there anything graphed anywhere? No. That's because if I put -20 in here, it's imaginary. Okay. So what's, as you're going left to right, what's the first value? Where's actually the first point? It's right here. And the x value there is 0. So can I actually put 0 in? I can. So that would be bracket. Now how about if I keep going this way? Are there any more problems? No. I can put in every other number I can actually put in. So infinity. Range, I kind of go bottom to top as if you're in an elevator here. So right about here, again, am I ever going to get -10 as a value right here? No. -10 is never going to end up. If I did an XY table, never get -10 for Y. And as you're going along, what's the first point again is 0. to infinity. How about absolute value? That's correct, because as you go left to right, are there any x values that I'm not allowed to put in here? If I was over here at negative 100, would there be some point graphed somewhere? There would. What about negative 20? Yeah, the point's right there. 0, yep, there's a point right there. Over here at 100, yep, there's a point. There is something actually graphed for that x value, because I can put in anything I want. Okay? Range, though, I'm never going to get a negative over there, because once you take the absolute value of something, yeah, the negative is gone. And so if you're thinking bottom to top, you keep going until you actually hit a point on this graph, which is at 0 for a y value, and everything above that works, so that is correct. I'll put it right here. Again, x values that actually give you something. Yes. Okay. That is correct. You can, and normally what would happen, people would put this one first, but it doesn't really matter because you do normally go left to right. If I was out at negative infinity, so maybe out here at negative 1,000, do you agree this graph would keep coming up along that asymptote? So is there actually something graphed there? There is. Okay. But as you're coming in like this, it goes down. Does it ever actually get, as you're going left to right, you're coming in like this, do you ever get to 0 as an x value? No, there's an asymptote there. So you never do. So that's why he said go from negative infinity all the way to 0. But I can't include 0 because that point never gets hit. But then from 0 to infinity, basically you start right out here, and you keep on going, all of those points you get. So if you look here, look this way, the only x value that doesn't get graphed, right here, 0. So some people would say all reals except 0. Is that another way to say this one? Yeah. But if you use an interval, that's probably the quickest way. And basically, once you know that, that's very helpful. The range is the same thing. You can go from negative, there's all these points down here as you work your way up, but a y value of 0 is the one that doesn't get hit. So we'll just go like this.